Hello, everybody, and today I'm gonna introduce the POX controller and working with a load balancer. And I assume you already know what is a load balancer. And load balancer is a way to redistribute the packet or the data flow in the networking. So just in case there's a too much data flow into one server, and we designed the load balancer so more server can be designed in a way to get separate amount of data, so they can better balance the functionality and the computational ability of the whole networking. Okay, so in this load balancing, which seems to be more simple, so let's take a look at our the source code. So in this experiment, as I mentioned, I will use the code from the POX controller. And POX controller is the default one, and we enter into directory of a POX NISC, and then you will see one of them is IP load balancer. So we open the load balancer, and actually we can see the code is not that long, and I'm not going to talk about the details of the coding. Instead, we'll show you guys I will show you guys here. So how they distribute the data in the network. Actually, right here. So this coding is very important because it created a data structure to save the server and to distribute the server, and the way is hashing, and the data structure they use is a Python dictionary, and Python dictionary is the hash map, as you know. Okay, so with this source code, I will show you how to do the load balancing. Now let's get started. So we can open a terminal. So first of all, I want to create a topology. So sudo meaning that topology is single switch with a 6 host. The controller is remote, and the port equals to 6633. Sorry about that. Controller. Okay, now we have a switch connected to 6 hosts, and we're using the remote controller because we're not using the default one, and we're using the controller with the functionality of the load balancing. Okay, then we open the terminal of H1 and H2. So I'm gonna treat this host as a server. Remember, there's 6 hosts in total, and 2 of them will be the servers, and 4 of them will be the clients. So I will make it become become a simple HTTP server. Simple HTTP server 80. Now it's working. And it will show you the detail later with the M, with the dash M. Python M simple HTTP server 80. Okay, it's working. Now we're gonna go back to the terminal. Let's open a terminal because we need to let our controller running. So we're gonna go to the root. So when you enter the home, the second step is to enter the user. So the user is my name. So we enter the user. After you enter the user and type the following command, and you will start the load balancer controller. POX pi log level debug misc IP. Remember, the misc is the folder and which contained IP load balancer, the P file. Load balancer IP address equals to the server IP address equals to 10.0.1. Servers equals to 10.00.1. Okay, why the server has two addresses? Because with this topology, and we're using the default address for each host. So the address of each host is from H1 to H2 is 10.0.0. From 1 to 8, from 1 to 6. So the first two hosts are the point 1 and point 2. So they're servers. And this is a load balancer address. So let's check if there's no problem and we can use it to start the controller. Okay, so the controller is running. So we can we go back to MiniNet and we casually turn any host, maybe host from 3 to 6, maybe host 5. So from host 5, we will use cur. Use cur to request towards the address of the IP load balancer. So the first task has been dealt with the H2. What about we cur it again? Cur it again, 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 again. So you can see based on this data, so the traffic actually have been redirected, casually redirected into the H1 and H2. Why casually? Because they're using the data structure of a dictionary of a Python. So you can see more detail like that. So now we're gonna turn back to the MiniNet and open a new window of maybe H2, H6. So it is the same. Curl 1. So it'll work. as a load balancing. Okay, so that is all for the experiment. I hope you like it. See you next time.